Hi, my name is Dinesh Raj, and this is my 8 puzzle solver. So let's show the code running by opening up a new terminal and going through the program. Python 3 main.py, and let's use A star as an example with Manhattan distance on easy. So at the very end of my program, once it's hit the goal, it starts climbing up all the way up to the root, as you can see here, and it starts printing. So this is the start configuration for easy, and then it prints out the current state of the board after performing an action, and it details the cost and the total cost of the path so far. So that continues on until we hit our goal state, as you can see here, and it also prints out some useful diagnostics to tell the efficacy of the program. If you wanted to run the code again or with a different algorithm or a different heuristic, you can do that as such. So now to go through the program, I have a main that only handles the user input. It has dictionaries that match the numbers that the user give it to call specific functions with specific difficulties. I have a node class that takes in state, parent, action, depth, and cost, and it has a bunch of useful methods like misplaced, H1, H2, total cost, Manhattan. Misplaced is used for greedy best firsts sort, H1 and H2 for A stars sort, and total cost for uniform costs sort, and Manhattan distance is used in H2. So let's get into the successor functions. So I have 4 functions: move right, move left, move up, and move down. These all pretty much do the same thing. They copy the current node and create a new node with updated information like the action plus 1 depth. But the only difference between these functions is that they check if, with respect to their name, if moving left, up, right, or down is a valid move. So you can see for left it's 0, 3, 6. For up it's 0, 1, 2. This function also calls is visited to see if this state has been visited before. So this is where I handle repeated state checking before I even add it to the queue. And all of these are called by my expand function, which will take in a current node and call all of move left, right, up, and down. And right here is where I check if it's the goal. So just to elaborate a little more, this is my isVisited function. Basically just checks if it's in visited. I use a set for visited for quicker access, and it returns true if it has been visited, else it'll add it to the visited set. So the differences in my program really come or the difference in the algorithm come from the queue management. So for depth first search, I have a stack, and I add to the end of it, and I also take from the end of it. I pop from the end of it. For breadth first search, I pop from the end of the queue, but I insert at the beginning of the queue. For A star, there is no specific order in which I add things. So I just add it to the end, but before I pop something, I sort by either H1 or H2, depending on which one the user wants to see, whether it's Manhattan distance or misplaced tiles. For uniform cost, I sort by the total cost, and I pop the lowest total cost. Again, for all of these sorting algorithms, or for all the algorithms that sort the queue, I always pop the lowest value one. It just depends on what parameter I'm sorting by. So for greedy best first, I sort by the number of misplaced tiles, and I pop the lowest value of misplaced tiles. Right here is how I handle timeouts. Is my check timer function. And